Hi, welcome to Curve Sketching. Take a look at this graph. Look at it. It's a pretty beautiful graph. Because it is cubic, you will notice that sometimes the graph goes up from left to right, such as right here or right here. These are called intervals of increase. However, there are other times whenever the graph instead decides to go down from left to right. These are called intervals of decrease. Intervals of increase are so called because the function is increasing at that point, or over those intervals rather. Intervals of decrease are so called because the function is decreasing in those intervals. Now you will notice that there are also some points on the graph where the function is neither increasing nor decreasing. These are called either local maximums if they're going from increasing to decreasing, or local minimums if they're going from decreasing to increasing. This is so called because if you're going from increasing and then suddenly start decreasing, the last point in which you were increasing is going to be the maximum point before you start plunging into the depths of hell. Meanwhile, it's called a local minimum because if you're plunging yourself into the depths of hell and then suddenly start skyrocketing again, then that is going to be the lowest portion in which you have, and thus the local minimum. In any case, these local maximums and local minimums are directly tied to whenever the derivative of the graph, shown here in blue, crosses the x-axis. So take a look here. X equals -2, y equals 0 on the derivative. And what you're looking here, it is a local maximum. Meanwhile, over here, y equals 0, and as a result, you have a local minimum right here. Alright, that's all fine and dandy, but you know what they say, if you can't do it with numbers, it's not worth our time, so let's do it with numbers. Here we have the original function. Here we have the function's derivative. The original function is x cubed plus 2x squared minus 4x. Derivative is 3x squared plus 4x minus 4. The first step in order to find the local maximums and minimums is to find what are called the critical points. The critical points are whenever the derivative of a function happens to equal 0. Or the y of that one happens to equal 0. So what we do is we take our y prime, turn it to 0, and then solve for it. Here I've done it using factoring, and we get y equals 0 whenever x equals -2, or whenever x equals 2 over 3. That's the first step. These two are our critical points. Now what we do is we take our factored form and we input different numbers in which are both to the left and the right of each of our critical points. So let's start with -3. Input -3, we get two negatives, that equals positive. So we know that up to and not including -2, the function is increasing. So that's an interval of increase at x equals -infinity to -2. Now what we do is we plug in a point which is in between these two. In this case, I plugged in 0. Plug in 0 into here, and what you get is a negative and a positive. And negative positive turns into negative. So we know that this is decreasing from x equals -2 to x equals 2 over 3. Now, of course, since we're going from an interval of increase to an interval of decreasing through x equals -2, we know that it's going increasing to decreasing, and therefore this is a local maximum. A local maximum will be found right here. Let's keep going for checking the critical points. Something which is after 2 over 3, what about 1? Let's put in 1. And what we get is two positives, and therefore that is all positive. And therefore it is increasing from x equals 2 over 3 to infinity and whatever the heck lies beyond. So this is going from decreasing to increasing, and therefore we know that it is a local minimum. And it will be located at the critical point, x equals 2 over 3. Now, we're not quite done yet. What we still need to do is we need to find the y values of each of these local maximums and local minimums. So what we do is we take our original function and we plug in these two into it to get our local maximums and minimums. I've done that right here using the power of a calculator. We have a local maximum at -2 and 8, and we have a local minimum at 2 over 3 and -1.48 repeating. And that's how you use numbers to find local maximums and minimums. Tune in next time where we draw infinite squares all over a graph.